In this lesson, we are going to go over complex numbers. Specifically, our goals are to understand complex numbers, to simplify square roots of negative real numbers, and to perform arithmetic operations with complex numbers. Okay, so introduction. So remember that the square root of 25 is 5, and again, that is because 5 times 5 is equal to 25. But what if we have the square root of negative 25? You may guess negative 5, but negative 5 times negative 5 is positive 25. Okay, so when you have the square root of a negative number, you will not find a real number that you can multiply by itself to get a negative, because a negative times a negative is a positive, and a positive times a positive is also a positive. So this is where complex numbers are going to come into play. So let's talk about them. So the imaginary unit I is what we're talking about, the icon that was at the beginning of the notes. So the imaginary unit is defined as I squared is equal to negative 1. And for our class, we're going to use what's called the principal root. Really, what you can just remember is that what we're going to be using is that I is equal to the square root of negative 1. Okay, so when an imaginary number is squared, we get a negative number. And this is how we're going to be able to take like the square root of negative 25, like I just showed you. So for instance, with 5i, if we square it, this is equal to 5i times 5i. 5 times 5 is 25. I times I is I squared. And remember, I squared is negative 1. So this is 25 times negative 1, which is negative 25. So that's what I mean by when we square an imaginary number, we get a negative number. Okay, so let's do some examples. So simplify. The square root of negative 25. As you just saw on the previous slide, it's 5i because 5i times 5i is negative 25. Well, let's talk about how to break this down. What we're really going to be using is the square root of negative 1 equals I. Okay, so the square root of negative 25 can be rewritten as the square root of negative 1 times 25. And if we break it up, square root of negative 1 times the square root of 25. The square root of negative 1 is I, and the square root of 25 is 5. So I5, or let's just talk about this as 5i, okay? Same thing for part B, the square root of negative 81. So we break this up as the square root of negative 1 times 81. So whenever you have a negative under your radical, you want to write that as negative 1 times whatever is left so that we can use negative 1 is equal to I. Okay, so we keep going. Negative 1 times the square root of 81. And again, this is I, this is 9, so our answer is 9i. Okay, and you can check if you do 9i times 9i, we get 81 times I squared, which is negative 81. Okay, so that's why 9i is the square root of negative 81. For part C, we have a negative on the outside and on the inside, so we're going to talk about what that looks like. Okay, so on the outside, when you just see a negative in front, you can think of this as negative 1. So this is negative 1 times the square root of negative 100. Okay, so I'm just going to work with the square root of negative 100 right now. Square root of 100. So this is going to give me 10i. Okay, so the square root of negative 100 is 10i. But remember, we had that negative in front. So this is negative 1 times 10i. So in this case, it would be negative 10i. Okay, and again, this negative is from the negative in front. That was at the beginning of the problem. Okay. Example number 2, simplify. So for part A, the square root of negative 32. So as I mentioned, whenever we have a negative under the radical, we want to write that as negative 1 times whatever's left. Okay, so I'm going to write this as negative 1 times the square root of 32. Okay, so we know that the square root of negative 1 is I, and now we have to break down the square root of 32. And we break this down the way that we've done previously. So square root of 32, however you want to do it. So 32 breaks down to 16 and 2. 16 is a perfect square. Okay, so the square root of 32 is equal to 4 square root of 2. So if we put it all together, the square root of negative 1 is I. The square root of 32 is 4 radical 2. So this is 4i square root of 2. Okay, and really writing it as 4i square root of 2 is for order. That's the way that you'll typically see these in any problems or typed out as well. Okay. So part B, similar idea. We're going to rewrite this as -1 times the square root of 54. We know what the square root of -1 is, and now we have to work with the square root of 54. So 54 breaks down into 9 times 6, where 9 is our perfect square. So the square root of 54 is 3 square root 6. Okay, so if we put this together, this becomes the square root of -1 times 3 square root of 6. Okay, and the square root of -1 is I, so this is 3i square root of 6. Let's talk about complex numbers. So complex numbers come in the form of a plus bi, where a and b are real numbers. So numbers like 1/2, 1, 2, -10, so on and so forth. I is what's called the imaginary unit, which, as we talked about, I squared is -1, or the square root of -1 is I is what we're using. A is referred to as the real part, and B is referred to as the imaginary part. Okay, and so some examples of imaginary numbers would be like 5 plus 2i, -10 plus I. 3i is an imaginary number. Sometimes this is called a pure imaginary number because there's no real part to that number. Okay, so we can do some arithmetic with complex numbers. So we will talk about adding and subtracting complex numbers. When you're doing this, you're collecting the real parts and the imaginary parts, similar to collecting like terms. So example 1, simplify. So in part A, we have 9 minus 5i plus 8 minus 9i. Okay, so everything's addition here. There's no operations inside the parentheses, and there's no other distribution. So we can write this as 9 minus 5i plus 8 minus 9i. Okay, and then our like terms here are we're going to collect the real parts together and the imaginary parts together. So we have 9 plus 8 minus 5i minus 9i. Okay, and then we simplify. 9 plus 8 is 17. -5i minus 9i is -14i. Okay, so the answer here is 17 minus 14i. For part B, we have 14 plus 8i minus 6 minus 2i. So when you have a negative in front of a parentheses, you may think of it as distributing the -1 to each of the terms inside of the parentheses. So this becomes 14 plus 8i minus 6. -1 times -2i becomes positive 2i. Okay, and again, we collect our real parts and our imaginary parts. So the final answer here is 8 plus 10i. Okay. Next, what we'll talk about is multiplying complex numbers. So you can still use distribution or FOIL, and then just remember that I squared is equal to -1. So example 1, multiply. So we have 2 terms times another 2 terms, so you can use the FOIL method. So that's what I'll go over here, where we do first, outside, inside, last. Okay, let me get some different colors here. So if we multiply the first 2 terms, that's 6 times 2, which gives us 12. The outer 2 terms, 6 times 4i, which is 24i. The inner 2 terms, 5i times 2, which is 10i. And then the last terms, 5i times 4i, which is 20i squared. Remember, I squared is equal to -1, so this is 20 times -1, which is -20. So if we put this all together, we have 12 plus 24i plus 10i minus 20, and we combine our like terms, or we collect our real parts and our imaginary parts. Okay, so 12 and -20, so this is -8, and we have 24i and 10i, which is 34i. So our answer here is -8 plus 34i. Our last example, we're going to multiply 8 plus 3i times 3 minus 7i. Okay, and you can remember to distribute. So I'm going to take the 8 and multiply it by 3, which is 24. 8 times -7i, which is -56i. 3i times 3 is positive 9i. And 3i times -7i is -21i. Okay, I squared, I'm sorry, -21i squared. I times I is I squared, just like x times x is x squared. Okay, so let's continue to simplify. So we have 24. 56i plus 9i is 47i. negative 47i. Okay, and now here, remember that I squared is negative 1. So this is negative 21 times negative 1. So when you simplify this, negative 21 times negative 1 is going to be positive 21. So this becomes 24 minus 47i plus 21. Okay, so now we combine our like terms. We keep going, 24 and 21. This is going to give me 45 minus 47i. Okay. Thank you for watching. If you have any questions, please feel free to reach out to me.